Alrighty, welcome back. In this video I'm going to review my solution to problem number 10. As you will notice, problems 6, 7, 8, and 9 have not been reviewed. These problems are very similar to what we saw in problems 1 through 5, therefore I will leave it to you to come up with your own solution on these. If you have any questions on them, of course you can stop by in the afternoon to ask for help. You can drop me an email or however you want to contact me. In this problem I'll go through and talk about the setup real quick. What we're doing is we're looking at three different alternatives, specifically the costs associated with these alternatives. And what we're wanting to do is find the most feasible one. And the key thing to remember here is that when we have no other alternative or no other information in the problem, we should always try to minimize cost within that problem. So in this case, what I've done is I went through and identified the information that we have available. In alternative A, we have a fixed cost of $100,000 and a variable cost of $20 per unit. Alternative B states that we have a fixed cost of $200,000 with a variable cost of $5 per unit. And finally, alternative C has a fixed cost of $150,000 with a variable cost of $7.50 per unit. So with this information then, what I have done is I've used Excel to go through and establish a cost equation for each of our alternatives. Alternative A, alternative B, and alternative C. In order to create this equation, what I have done is I've just taken the fixed cost plus the quantity times the variable cost. And so with each one of these I just set up that equation, and with that then I copied it down through the table. Now my quantity, I started at 1,000. You could easily start it at 0 if you wanted to, and just incremented it up to 30,000. The problem statement says that a typical production run is upwards of 30,000 units. So I ran it through 30,000, and in this problem that is adequate because you can see that the relationships are linear. So okay, so what I did was once I have my table created, then I went through and used a scatter plot to create my graphs here. And in this case what we see is that the black graph here represents the cost associated with alternative A. The red line represents the cost associated with alternative B. And finally the blue line represents the cost associated with alternative C. And as I already mentioned, we have to keep in mind that our goal is always to minimize cost if we know nothing about anything else in the problem. So with this then we can see that when we're dealing with minimum cost, the alternative A has the minimum cost through this point of intersection here. So from 0 units to this point, the first alternative represents the least cost. So what I did was I went through my table then and found that alternative A equals alternative C at 4,000 units. So that means that alternative A is the most feasible when we have fewer than 4,000 pieces of production that we need to produce. From that 4,000 units then we see that alternative C is the most feasible, and that C alternative is most feasible until this point of intersection because it represents the minimum cost. It's the lowest line. So once again I went through my table and found that this point of intersection where alternative B equals alternative C occurs right here at $300,000, and it turns out that that cost is associated with a production of 20,000 units. That means that from 4,000 units to 20,000 units, our alternative C is the most feasible because it results in the least cost. And then naturally Beyond the 20,000 units, we have alternative B taking over. It then becomes the most feasible. So for a small quantity, alternative A is the most feasible. For an intermediate number of products, alternative C is the most feasible. And for a large quantity of products, quantities of over 20,000 units, alternative B is most feasible. So I hope this has given you an idea of how we can use Excel to solve some of these more complex problems. A table like this, if we were to complete it by hand, would take considerably longer because of course we'd be doing all of these calculations manually. In addition, we could have gone through and used a little bit of linear algebra to set up the equations and find the point of intersection. However, that would in my mind be somewhat abstract and somewhat more difficult to qualify. When we have a nice graphic as we do here, this plot very nicely illustrates the fact that in fact we have least cost represented in different regions. So I hope this has been helpful. If you need any help with this assignment or any assignments throughout the quarter, please make sure that you give me a call or drop me an email. I'll try to respond to you in the afternoon. Again, I'm typically available from about 2 p.m. to 5 p.m. or thereabouts. So anyhow, if you have any questions, let me know. Thanks a lot. Hope this has helped.